Hey guys, hope you guys are all doing well. So today we're going to go over our last part of this section that we need before this quiz coming up next week. So today what we're going to do is we're going to use those double angle identities to try to solve equations. Okay, all right, so this is actually your assignment for today, and what I'm going to do is for the notes, I'm going to pick two of these problems to do with you guys, and then I'm just going to ask that you finish the remaining three problems. All right, so the one I want to focus on first is problem number one. So we have sine of 2x plus cosine of x is equal to 0. Now, anytime that you're working with these equations and you see the only double that you have is in terms of sine, sine's pretty easy because we know that sine only has one identity that we can use, right? We just have 2 sine A cosine A. So I'm going to take that and I'm just going to plug that in. So we're going to end up with 2 sine x times cosine x when I plug it in. Now we still have our plus cosine x there, and this equation is still equal to 0. All right, so now that you guys are at this point, once you plugged in, now you want to try to start solving this equation. So we know it's really tough when we have multiple trig functions actually going on. So what we can do here to kind of separate some things is if we look at this as two groups, like here's our one group right here, there's our other group separated by that plus sign, we can actually look through and look to try to factor. So if I look at those two groups, I know in common they have a cosine x. So I can take out a greatest common factor of a cosine x, and that's going to leave me with 2 sine x plus, and then just remember when we take a cosine away from cosine, there is still something there, and in this case you're left with 1. So we have cosine x times 2 sine x plus 1. So the reason why that's helpful is because now you have two totally separate groups separated by multiplication. So this is when we can take each of these groups, and again, I'll underline these groups that I'm referring to in blue. Here's the two groups I'm talking about. So you can now take each of these groups and set each of them equal to 0 and try to get that trig function by itself. So when we set cosine x equal to 0, that already has cosine x by itself. That's fine. So now we have to take 2 sine x plus 1 and set that equal to 0 and solve 2. So when we solve that, we're going to end up solving for sine. So we end up getting sine of x is equal to a negative 1/2. All right. All right. So just remember when you guys are going through and actually doing like the solving process, what we talked about at this point. So, you know what? I'm actually going to go through and solve this right side first. I think it might be a little bit easier. So when we have sine x is equal to a 1/2, remember, sine is really represented by y. So what we're saying is that y is a negative 1/2. So if my y value is 1/2, I know my x value has to be root 3 over 2, which means that I know I'm working with the special angle of pi over 6. And since y is a negative 1/2, that means I need my quadrants that produce y as being negative, which is quadrant 3 and quadrant 4. So when I go to write my final answer for that right side, I'm going to always have to go one more or one less for my closest x-axis. So since we know in quadrant 3, my closest x-axis is 6 pi over 6. If I go one more, that's going to give me 7 pi over 6. And then quadrant 4, my closest x-axis is actually a 12 pi over 6. So if we go one less, it ends up giving us 11 pi over 6. So those are our two answers from the right side. Now, if we look at the left side, we have cosine x is equal to 0. So remember, cosine goes with x. So whenever you have like 0 or 1, whenever you're working with cosine or sine, remember, you're going to fall on an axis. So since we're saying that x is equal to 0, we want to think about which points give us an x value of 0. And the 2 points that corresponds to is our positive and negative y-axis, because this is 0, 1, and this is down here 0, negative 1. So then those are the two angle measures of pi over 2 and 3 pi over 2. All right, so that would be our 4 answers for this problem. All right, so let's go through, and the only other one I wanted to do with you guys, just because cosine can get a little tough, is I wanted to walk through problem number 4. All right, so in problem number 4, we have cosine of 2x minus cosine of x is equal to 0. So when we go through and we use our double angle identity, the only double angle we have is that first one that I just underlined in red. Now, when you guys go over here, remember, cosine has a lot of different ways that you can rewrite it, right? And you have to know which way is going to be most beneficial to you. So whenever you're working with this problem with cosine, kind of keep in mind whatever that second term is. And whatever that second term is, you want to use the identity that keeps those trig functions consistent. So in this case, I'm going to pick the second one because when I do, I know I'm only going to be working with cosines. So when I plug that second statement in there, I'm going to have 2 times cosine squared x minus 1. And then I'm going to have my minus cosine x. And that's going to be equal to 0. All right. Okay, now when you guys get to this point, if you look, you have 3 terms going on, right? And I'll underline these in blue. Here's one, here's another, and there's your third. So what we want to do, and what's going to make this a little bit easier for us to kind of see, is we actually want to take this and rearrange these. So when I rearrange them, I'm going to keep my cosine squared first, but then I want to keep my cosine to the first power second, and then I want to keep that constant term, or that 1 that's by itself, all the way at the end. So you have 2 cosine squared x minus cosine x minus 1. And the reason why we do that is because what we just wrote, this is the same exact thing as saying 2x squared minus x minus 1. These two are the same exact thing. It's just now you're working with cosine instead. So at this point, once you have this, you have to try to factor. So it's not like taking out a greatest common factor like that first problem was. In this case, when you factor, you're going to factor this and have to break this down into your 2 sets of parentheses. So your factors with 2 cosine squared x are going to have to start them. So I know I'm going to have a 2 cosine x and just a cosine x. Your factors of 1 have to end them. And then just be careful with your signs. Because this is a minus 1 at the end, I know my signs have to be different, but I need to try to get a negative 1 in the middle. So I know this has to be a negative because my outside terms then give me a negative 2. And that's got to be a positive because my inside terms would then give me a positive 1. All right, so once you guys have that factored, now this is just a matter of taking both of these groups right here, and just like we did, set them equal to 0 and try to solve. So if we look at our left group first, when we set that equal to 0 and solve or get cosine by itself, we end up getting cosine x is equal to a negative 1/2. And I'll just stick through trying to solve this left side first before I focus on the right side. All right, so now that you're here, we're working with cosine, which we know is x. So we're saying x is a negative 1/2. So that means the special angle I'm working with is pi over 3. And since that 1/2 is negative, we need to figure out the quadrants which x is negative, which is quadrant number 2 and quadrant number 3. So using pi over 3 to get an angle measure in quadrant 2 and quadrant 3, we're going to end up getting 2 pi over 3 and 4 pi over 3. All right, when we look at our right side and we solve for cosine, we're going to end up getting cosine x is equal to a positive 1. So when we get cosine x is equal to a positive 1, remember, we're still working with x, and we're saying x is now a positive 1. So this is not going to be like a pi over 3, pi over 6, or pi over 4. This is actually going to lie on the axis again. So where we know, if we think about all of our ordered pairs where x is a 1, is just that 1 point right there, because that's the ordered pair 1, 0. So that 1 point right there corresponds to the angle of 0. If you want to put 2 pi, I'm okay with it. Not a big deal. I know that they're the same exact thing. So you could put a 2 pi too. But for this problem, we only end up getting these 3 answers. Okay, so if you guys need any help, like always, hop on that Google Meet session, email me, comment through Google Classroom. Any way that I can kind of get back to you guys and help you out with this stuff, more than happy to do it. All right, I hope you guys have a good rest of your day, and I'll see you later.